Today's episode is just about the concept of energy. So we know that the concept of energy was first introduced by Newton when he hypothesized about kinetic and potential energy. We know what is kinetic energy and potential energy, but we don't know who came about these forms of energy and who introduced this energy and who hypothesized about this energy. And all this history we are hearing about energy was something that was done by Newton. And we all know that Newton was a famous scientist. So, however, the emergence of energy as a uniform concept in physics was not adapted until the middle of the 19th century and is considered one of the major scientific achievements of that century. So, energy is a scalar quantity that cannot be observed directly but can be recorded and evaluated by indirect measurement. The absolute value of the energy of a system is difficult to measure, whereas the energy change is relatively easy to evaluate. So the sun is one of the major sources of the earth energy. Are you getting me? The sun is one of the major sources of the energy. So there's an energy balance between the earth and the sun. There's an energy that is released by the earth towards the direction of the sun, and there's an energy that is released by the sun towards the direction of the earth. So energy is associated with the structure of a matter and can be released by chemical and atomic reaction. Throughout history, the emergence of civilization has been characterized by the discovery and effective application of energy to help meet society needs. So there are different forms of energy, but energy manifests itself in many forms, which either internal or transit. Energy can convert from one form to another. In thermodynamic analysis, the form of energy can be classified into two groups. That is the macroscopic and the microscopic energy forms. So with the microscopic form of energy, these are this form of energy that an overall system possess with respect to a reference frame. Example, kinetic and potential energies. For example, the macroscopic energy of a rising object change with velocity and evaluation. The microscopic energy of a system is related to motion and influenced by external effects such as gravity, magnetism, electricity, and surface tension. The energy that a system possesses as a result of its motion relative to some reference frame in kinetic energy. Kinetic energy refers to the energy of a system because of its overall motion, either translational or rotational. Either translational or rotational. Overall is used here to specify that we refer to the kinetic energy of the entire system, not the kinetic energy of the molecules in the system. If the system is a gas, for example, the kinetic energy is the energy due to microscopic flow of gases, not the motion of individual molecules. So the potential energy of a system is the sum of the gravitational, centrifugal, electrical, magnetic potential energies. The energy that a system possesses as a result of its evaluation in a gravitational field is called gravitational potential. So you can see over there I give some example with a little calculation, but I did not do the calculation mathematically, I decided to use English in doing that calculation. And as a kinetic and potential energy depend on the environment in which the system exists. In particular, the potential energy for system depend on the choice of a zero level. For example, if the ground level if ground level is considered to be at zero potential energy, then the potential energy of the mass 100 meters above the ground has a positive potential energy equal to the mass, which is 1 kilogram, multiplied by the gravitational constant, which you know that G is equal to 9.807 meters per second, and height above the ground 100 meters. It is potential energy will be 980.7 kilometers per second square, or in newtons it will be 980.7 joules. So with the microscopic form of energy is a form of microscopic form of energy are those related to the molecular structure of a system and the degree of molecular activity, and are independent of outside reference frame. The sum of all microscopic form of energy of a system is its internal energy. So the internal energy of a system depends on the inherent qualities or property of the material in the system, such as composition and physical form, as well as the environmental variable, which is the temperature, the pressure, the electric field, the magnetic field, to mention but few. The internal energy can have many forms, including mechanical, chemical, electrical, magnetic, surface, and other forms of energy. So you have to take this into consideration that all forms of energy are expressed in the same unit, which is the joules, megajoules, gigajoules, etc. So some definition of some form of energy, which is the mechanical energy, the thermal energy, the nuclear energy, and the the chemical, nuclear, thermal, and mechanical energy. As you can see, these are some definition of the energies, some form of energy that we have. So I'll proceed basically and ask a question that are we running out of oil? If yes, what is the cause? If no, why did you say that you are not running out of oil? This is going to be our next topic in the next episode. Thank you for watching. Don't forget to subscribe.